Sally and Sam are studying turtles who are colonizing the many islands of the Florida Keys. They are studying 3 islands: Coconut Island, Palm Island, and Orange Island. They counted the number of turtles on each island starting in year 0 and collected data over the years. They found functions relating the years to the number of turtles on each island. Here are the functions for the turtle populations on each island. X represents the year, and Y represents the number of turtles for each year. Here are the graphs for each function. Can you match each equation with the correct graph? Let's look at the equation for the turtles on Coconut Island. Is this equation linear, exponential, or quadratic? Y equals 3x plus 20 is a linear function with a slope of 3 and a y-intercept of 20. The only straight line on the graph is here. Coconut Island started with 20 turtles, more than any other island, but the population only increased by a constant 3 turtles per year. Now let's look at the equation for Palm Island. Y equals x squared plus 15 is a quadratic function. It has a vertex at 0, 15. If we zoom out, we can see that this function has the classic symmetry that is typical of a quadratic. As x increases, an increasing quadratic function will always surpass a linear function. Finally, let's look at the equation for Orange Island. Y equals 2 to the x is an exponential function. The initial value is 1. We see that here in the equation. Which graph has a y value of 1 turtle for an x value of 0 years? This graph has a y-intercept at 0, 1. It must be the graph of the exponential function for Orange Island. Notice how quickly the turtles grow. Exponential growth functions will always eventually surpass linear and quadratic functions as x increases. Sally and Sam used their graphs of turtles over time to see that the turtles on Orange Island will eventually increase beyond those on Palm Island. And the turtles on Palm Island will eventually increase beyond those on Coconut Island. That's because exponential growth always beats quadratic growth, and quadratic growth always beats linear growth.